doing today? Woohoo! Okay, are you ready? This is Vibe Coding 101. I hope you're in the right session here. My name is Robert Hoffmann. I'm a solutions architect at AWS. And today I want to talk a little bit about how to make your AI coding assistant better. So the problem here is, right, when I created the title for that talk, that was like a few months ago. Obviously, that means a lot of stuff changes in the AI coding community. And I try to give you an update on what's currently going on. And the techniques, the mechanisms I show you, the services I show you, these are things you can use to improve your AI coding agent, whichever coding agent you're using. Or if you're even building your own coding agents, you can use the same techniques. So take the building part as could be building, could be completely coding an agent from scratch, could be using an existing AI coding agent and configuring, composing it the right way. And with this knowledge, you can improve your day-to-day work, but you can also help others, especially if you're like a platform engineer. But first of all, let's celebrate this moment, right? What a time to be alive. I've seen the light. I can tell you, every developer can absolutely create 10x more useless code. And why, amen, yeah. And why is that? That's because we were missing something. And the something has a name now in the community. Many people did it before that, but as you always know, some people already figure things out, and somebody else names it. So one part of the equation is context engineering. And where it all started, and I even did it like this myself, is like you did prompt engineering or vibe coding. You just gave the agent a task, short sentence, build me a web app, and hope for the best. And now the community is coming around to context engineering. So the idea is like, how do I actually boot my LLM, boot my AI agent to have all the context I need so that the output is kind of good, hopefully, maybe. And Andre Karpathy, who's also kind of the inventor of the term vibe coding, he is kind of, I think he didn't invent context engineering, but he's kind of supporting this idea of being a delicate art and science of filling the context window of your agent with just the right information for the next step. And what that means in practice is something I want to dive a little bit deeper into, and I'm also showing you some examples. And as it's a tradition when talking about AI agents to compare them to a computer, I will do the same. So you can think about your AI agent as having kind of a CPU, which is the LLM, right? Takes the instructions, takes the context window, does something for you. You have a context window, which is kind of your RAM. This is all the agent knows at this point in time to do the task. And you have external context or external storage, like a disk, because you can pass it files or you can ask it to write files. And finally, you have these expansion cards. Maybe if you're building your own computer, you know these large things, maybe GPU for your building, for your gaming rig. And these are your MCP server or external sources, which could be APIs and so on. Now, these are all just tools, things you can use with your agent, but you actually have to orchestrate that. And this is where context engineering comes in. Context engineering is really this idea of building, curating your bootloader for your agent operating system so that it has the right information. And for each of the things that you see here, there's also a task to do. So yes, you need to pick the right model, and there are multiple frontier models you might choose from. into the RAM, which is something that is limited. You need to load the right context. And then you might even have to unload context because it doesn't fit all into the agent, and you need to tactically decide what data you give the agent for the task at hand. And finally, you have that super external knowledge, which could be those MCP servers, those servers that give the agent access to additional APIs and information. So how do you set up that bootloader? And again, this basically all works with every AI coding assistant, whether you build it on your own, whether you're using Copilot, Cursor, whatever. It differs in like what commands you can use, how you need to structure the prompts, but the ideas always work the same. And the basic tools you have to set up your bootloader is one, rule files, which are like reusable rules that the agent will use all the time when it takes a task for you. And these are typical things where you would define things like code styles, a project convention, and basically all the things where you want to tell the agent, always do this or go to jail or something else. And to top this all up, you also have workflows, or sometimes they are called tasks or scripts. So the idea that on top of that basic rule set that the agent will also follow all the time, you might have very specific instructions for specific workflows and for specific tasks. So you might have a workflow, and I will show that to you in a minute, that gathers requirements, clarifies them, and creates a specification file out of it, because we want to engineer better context. Now, for the demo today, the agent I'm going to use is Klein. So Klein is an open source AI coding agent that you can use in Visual Studio Code. You can just download it. There's unfortunately one little problem. There's still not really a good open source LLM that you can run on your laptop, so you still need to go to the cloud somewhere and get some of the frontier models, like maybe Gemini or Claude, something like that. But a lot of the rest of the stuff is open source, and you could use that yourself. So to start off, I have some development guidelines here, and typically those are markdown files. And here I tell it to use some specific things whenever it does work for me. And this is just an example of a very standard rule file. That's not really something completely new. People have been doing that for a long time. And I can configure Klein with this handy button down here to basically say, hey, please use that rule file here whenever I want, and use it for your next task. The second thing that Klein supports are those workflows that I talked about. So here I have two. And you see from the name what they're supposed to do. They create a technical specification for me, and then after that, they create an implementation plan for me. And those kinds of workflows, they can be very involved, but they really help to keep the LLM, the agent, structured and honest about what it should do. And it also really helps to go to a thinking mode instead of acting mode, because this is typically where things go wrong. If you ask the LLM too early to do things, it doesn't do what you have in your head, so you give it more specification. So this is like how one of those specification prompts look like. And you can already see from afar, there's something like XML text in there that could be specific for your particular agent. But some of these agents really have an understanding of being super structured about these workflows. So they pick up those kind of tags and special markers, variables. So you can really think of it kind of like a bash script that is interpreted by an LLM, and the LLM will follow it very closely. So that helps for creating a specification. By the way, all those sources, the links to Klein, the workflows, the prompts, I will have a link at the end for you, so you can look it up later. So I have an example conversation I had with the agent from yesterday, and here you can basically say, see I use this like a script. So it's like you put in a slash, create technical specification, and then you might start with vibe coding. As you can see here, I just said, hey, help me create a media asset management service. But then, because you gave it that very structured workflow, it actually starts to dig into that. So what you can see here is it starts asking questions. Is that a standalone service? What is that actually? Now, what's the name of it? Help me about the core purpose. What should it do? So you see it starts to like pull out the information that I might probably have in my head or that I haven't thought about, and helps me to structure, to specify what I actually want. And all that information I'm giving it, we will use in the next step to create a solution that's closer to what we actually wanted. So the idea really is here to boot to spec-first mode. So we're not vibe coding, we're not giving it a small sentence and hope it creates the right thing, because it could go anyways and it can be very creative. Instead, we try to do this very structured, spec-driven approach to give it just the right and just enough context so that the whole thing goes into the right direction. Now, at some point, we need knowledge that even we might not have in our heads ready, right? And this is really about domain knowledge. Because the LLM is trained on some stuff, and it knows a lot of things kind of instinctively, but if you just let it work on that intrinsic knowledge, it can make a lot of mistakes and hallucinate stuff. So whenever possible, we want to nudge it back to ground its knowledge in reality. And we can do this with MCP servers. So I have an example here that at some point, so this goes on and on, I'm doing my specification stuff, I'm telling it how many users and so on. And at some point, it asks me, hey, what kind of approach do you want to take to actually build the architecture for that? And this is something I included in the workflow. So this is an idea that you could do at your company if you were a platform engineer and you're thinking about, okay, what are the typical golden paths that I want to present to my users? You can basically code this into such a workflow and share that with your users. So they already go on the right track when they think about implementing it. So obviously, I'm from AWS, so I put in something about AWS, and I said, yeah, let's do AWS serverless. And now something cool happens. Actually, Klein uses an MCP server from AWS, so they have a bunch now that connect to various services, to various knowledge banks about how to architect AWS services and architectures. And what it does here, it reaches out to one of those servers, and that server gives a high-level overview of how the LLM should architect that. And this is really cool because if you have seen MCP servers, a lot of the discussion is often about, oh, it can order a pizza, it can do this, it can do that. But you can also think about the MCP server as something that is purely for information retrieval. So you nudge the LLM, hey, use this MCP server to get that documentation. Use that MCP server to get an architecture approach on how you design it, what to think about, and so on. So it can be part of the prompt engineering because the MCP server can influence the LLM and tell it, hey, thanks for reaching out. First, you should, as you can see here, identify core components, think about architecture patterns, and so on. And then the LLM uses that information, particularly because I told it I want to use an AWS serverless architecture, and will use that in the rest of creating the technical specification. And the goal is basically to have this, right? So we're dropping those little pills of knowledge, but we need to be careful, and this is kind of still an unsolved problem where you cannot give every information to the LLM. That would be way too much, and it would get confused very quickly. You need to be very tactical and specific about, okay, I have all those MCP servers with all those knowledge bases. what is actually relevant for that task. And you can control that a little bit with a workflow like I showed you. So it's part of that workflow script that I wrote that is saying, hey, use that MCP server for that part of the job. By the way, if you haven't heard about MCP servers, so it's basically the idea that you can add additional functionality to your LLM. It's kind of like an API to whatever data you want. But the interesting thing is that it's not just like a REST specification. It really has some features where it has the LLM in mind, the agent in mind, so it can actually work together with the agent. So as we saw here, it doesn't just provide information, it also provides part of the prompt, part of an idea of how to tackle that task, and that helps the LLM. Now we're at a cloud native conference, so I have to also invent some term, ideally with micro. So let's talk about micro context, right? So micro context is basically just the idea of context engineering. So the problem with those LLMs is they have a context window, which could be like, for example, for Claude, it's 200,000 tokens. And if you fill all of that up with, hey, here are all my files, all my code files, here's all the MCP knowledge, here's whatever, all those websites. At some point, the context gets truncated because it needs to throw out all stuff. It's like RAM, right? You cannot compress it. It's finite. And then also what we see a lot, and this I think has been proven even by experiments and just experience from users, the fuller your context window gets, the higher is the chance that the LLM gets confused and does weird stuff. So even if you have a huge context window, let's say Gemini, you can do 1 million tokens, which is a lot, you still don't want to fill this that much. You want to keep it slim. So that's the idea of micro context. Instead of later trimming your context, starting over, we just start out with basically slicing the task into very, very small subtasks, and then just loading in the context we need for that small subtask, and that helps us to keep the context window small. So ideally it looks like this, right? Instead of throwing everything in there, we have those smaller tasks, and that's actually what I'm going to show you. So we've created a specification, and now we want to chop this down into tasks, and then the LLM would work on each task in a separate session, not in the same session where we already maybe filled the context window with like 60,000 tokens just to create the specification. So that's what I can show you here. So that's my second script, create implementation plan, and that thing again is a markdown file. It's very structured, and it says things like, okay, first find the feature specification that we've written before. So you see, it's not relying on some random state of its context window, but you actually tell it, okay, start again, load these exact files to get the context you need to implement the thing. And then create the implementation plan. And here you see things like, hey, please chunk this down, because we know, again, in the next turns, we want to have separate sessions with a micro context window that are working on these specific tasks. And how this looks like in the end is that it reads the files, and I will talk about memory bank in a minute, and then it comes up with basically chunks. So you can see it here. It says, okay, chunk 1, let's do the project foundation and the AWS infrastructure setup. And I'm not saying you're wipe coding your spec and this breakdown, because you might say, and that was my experience, that's still too big of a task. So you would still steer it and say, hey, I think that's too much. Can you break this down more? And then it works in smaller steps. And it writes all of this down as markdown files that you can use in the following turns. So let me close some things that I already showed you. Now, there's one more problem with that approach. If we have micro context, That means we also are throwing a lot of context away all the time, and we have to start over, otherwise our context window isn't small. So how are we actually going to do that? So typically, when you're using an AI coding agent and you use it today and you ask it to create something, well, it does the work, it's all fine, but then it's Tuesday, and you might start a new session and you say, hey, continue the implementation. And it's like, dude, what? Some agents are smart enough, right? They will read the files that are present in your project, and they might guess what's the next task or where they are currently, but really you're missing that context that you can load in back again, so it knows where to go off. And for that, to basically prevent this kind of goldfish memory that you have here, there are certain techniques that you can use. So one of them is a so-called memory bank. And that's actually a very large rule file for Klein. And the memory bank basically has this idea of telling the agent to always keep updated a bunch of documents that provide that content for the implementation task. And when it has that, it basically has a persistent memory. Of course, it's not perfect, right? It's not everything you had in the context window, but it creates a summary. It creates a kind of workbook of what has been done, and then can pick off from there. So in that case, when you say something like continue the implementation, work on the next step, it probably has like a progress markdown file, and then, okay, it knows, yeah, the next thing was to add a password strength meter or whatever. And the memory bank is actually actually uses some, let's say, advanced techniques. So it even gives diagrams to the LLM to tell the LLM how these different types of documents are connected and how it should manage them. But the idea is that from then on, you can feel safe in doing a small task and then starting a new session with an empty context window, because it will be told to pick up where it started off, where it left off last time, by reading that memory bank again. So whenever you see me doing these kinds of interactions, you might have picked it up already, you see it's reading that memory bank because it has that general rule set that is applied to all my sessions. So that's a rule, not a workflow, saying, hey, always first check the memory bank to figure out what's going on. Now, there's one more problem. You can do all those things, and it can still go wrong horribly, because that's the life of using LLMs. So a feature that I think at this point almost all coding assistants have is basically going backwards in time. So through tests and studies, we've seen LLMs have this rabbit hole problem. So they start doing some things, and then they do something wrong, and then you try to turn the wheel around. You try to steer them away. No, don't do that. Don't do that. But actually, people that are way smarter than me figured out, actually LLMs are very bad at getting steered away. It's basically better to kick them in the bucket and start new. And that's the idea of checkpointing. So the idea is you have this ideal path of how you want to implement it, and along the way, the agent creates checkpoints for you. And when you see, oh, this is actually not what I want, I go back to the checkpoint and I go back to a valid path. And that's actually something that comes more and more into the UIs of these agents, that you can try multiple variants, try again, and so on. And Klein has this as well. So whenever you look at the client conversation, you see here's this checkpoint line, and I can basically restore the whole project and the conversation back to that point to try again and go on the right path. So that's basically context engineering in a nutshell, and that's kind of the message I want to leave you with. So building your own AI code assistant, and building meaning, again, configuring, composing, or really writing from scratch. It's really all about context engineering, so thinking about how can you use those rules and workflows or script files to go into the spec first mode, add the right domain knowledge, focus on doing small sessions with micro context, persisting the context that you need again in another micro context session. And again, I need to reference something from our space, right? Shift left context. Shifting left context basically meaning you go back with your context to a state where it was still good. So you go more to the left of the implementation of your workflow and start from there to hopefully get a good result the next time. So that is really the gist of building or improving your own AI code assistant. And actually, AWS believes so much in this idea of spec-driven development, context engineering, that they just released a whole IDE called Kiro that embodies that whole idea. So to give you a quick view of that, it looks something like that. It's a Visual Studio Code fork. And what you can make out directly is, you see at the top, there are tabs for requirements, design, and task list. So in this editor, it's not just a bunch of workflows I need to work through with client, but it's actually even in the UI, this whole idea. And that helps a lot to create better outcomes. So that's it for now. If you want a link to all or basically most of the resources, please go to that link. The link is a small trap. You have to fill out a survey. It's 3 questions, and after filling out the 3 questions, you get all the links to what I showed you. I hope this was interesting to you, and you can now go build and work better with your agent. And one last comment, if you want to try out Kiro, unfortunately, they had to close the sign-up for that because the demand was so high. So I'm really sorry to inform you, you can only go on a wait list. And there's absolutely no way to install Kiro right now. You cannot even do brew install -- cask Kiro. That absolutely doesn't work to get the IDE, so don't try it out. Thank you.